Recording. So let's just talk about like schema design. So what we're going to do is we're going to design a new application or new database. We're going to, again, run through creating tables and then inserting data into those tables and then doing some querying on those. With that, let's talk about database design. As I mentioned earlier, designing a database, you should take as much time as needed to design the database correctly the first time instead of having to go update and manually modify databases. And just because once you have data within your database, you're not going to be dropping your database and just rerunning the schema file every single time, because you just can't drop your database with data in it. Especially if it's a production database, like if Facebook needed to update their database and they're like, oh crap, I need to add an extra column. It's not like they can't just drop the entire database and reload it with that column in there or that new table. So it's important to, take the time, design your database before you go ahead and actually write any code. So with that, we're going to actually create a new database, like a new school database that has like students, addresses, and guardians. Because, typically speaking, as a student, you may or may not have a guardian. So usually they're your parents or parent or a guardian of some sort. So we're going to have, addresses, students, and guardians. And I guess we can assume that the student lives with the guardian. So we provided a link in the schema design to this quick database diagrams. So this is an easy way to visually design your schema, and it automatically shows the connections. So again, we're going to create students, guardians, and addresses database. So if I needed to create a new students table, I can do addresses, and it automatically hey, here's the table addresses. If I needed to create a new table guardians, it create a guardians table, and we're going to create a students table as well. Can I zoom in on there? There we go. Is that better? So I've got addresses, guardians, and students. There's other database design applications out there, but this is just kind of quick and easy to use. So I have addresses, guardians, and students. And if you need help about how to use this, you can see the docs right here. It's relatively straightforward. So with addresses, we have an ID. It's going to be a primary key, and it's going to be an integer. It's okay that these don't match up, with raw SQL. You can, I think, was it Jarrett? You exported this, and it automatically, so you can export it, and it should export it into a SQL file, maybe.
Yeah, you can choose which of the formats you want to do it to, it does the different types of SQL. Yep.
Oh, cool. Nice. Yeah. So you can definitely do that. So let's say addresses has line 1, and that could be a string. Also have a line 2. That'll be a string. It's got a city. That's a string. I'm just doing this I'm not going into very specifics as far as the length of the string and all of that. I just want to design the table with all the columns and fields and just the data type. Once I actually go into writing the SQL table in raw SQL, we'll get into more detail then. I just want to get a visual representation of students, guardians, etc. We have city and we have state. String. Guardians, we have ID, which is a primary key, which is an integer. Let's just say name is a string. We have phone number. Let's take in a string because people generally, phone numbers are inputted as string versus integers. Email, let's say that's a string. And then the guardian, where should the address be? So say all the students live with the guardians, and say multiple students, a guardian can belong to multiple students. So let's just kind of figure this out first. Let's just do the primary key integer, and then we can figure out how they're all connected. Grade, date of birth. Let's just say that's a date. All right. So now we need to figure out where the foreign keys should go so we can connect everything. So we can say a student belongs to a guardian. So we can say, and a guardian can have like multiple students. Let's just say that. So on the students, we can have a guardian ID, which is integer, which is a foreign key, belongs to guardian dot ID. There we go. So this means the guardians can have many students. So that's how that's connected. Now, and let's just assume that students live with the guardians. So we can do addresses or address ID, integer, foreign key, addresses, ID. What's going on here? Address ID. There we go. Oh, that's not what I want. What questions do you have about like the visual representation of this? So now we actually have connections between all three of them. So if I wanted to get to addresses, or if I wanted to get to students from the address table, I have to go through the guardians table. So I have to grab the guardians, find the address ID, and then where, like on the students, where the guardian ID equals this guardian ID. Now this is a relatively simple database schema, but does anybody have any questions about how these are connected? Nope.
I have a quick question, Tom. What's the difference between, so if you see an addresses ID on that first line, and then you see the what do you call it? The connection, that gray line. We have like a cross on one, and then we have a branch on the other.
So this is a one to many. So if we look at the docs, let's say relationships. All right, I guess it's a many to one. So there's many addresses can be, sorry. Yeah, the address belong to many guardians. So one address can have many guardians.
Okay.
So if I change that around, I just want to see what this looks like. Oop. Yeah, so that's not what we want. And that's just kind of what that means. But we'll get into a little more complex application or database in a little bit. Let's open up a new window. What the hell? Where'd it go? I gotta find my VS Code. Oh, there it is. It's hiding behind. So again, I need cd desktop cp challenges. I'm gonna make a directory called SQL example cd and the SQL, and open that up. And then I'm just gonna create a new file called example schema.sql. I'm gonna code example schema. I'm just gonna open it up right here. So if I wanted to create addresses, guardians, students, and I'm gonna insert some data into there, and then we can manipulate that data. So judging from the past SQL basics, what's the first thing I should do at the very top? If I'm writing a new schema file.
Could you make your drop statement?
Yeah, let's make our drop statement. Drop table, if exists, is it students? And then always do cascade, just by default. The students, guardians, and addresses. So now we can actually create a table, addresses, an ID, we can serial, primary key, then line one, let's do varchar, just keep things simple, 255, not null. So address is the line one that has to exist. So line two, not all addresses have a line two. So if you like own a house, you're not going to have a line two in your address. But if you live in an apartment, you might have like apartment, 604 or something like that. So we don't want to not null here, but we want a default value to go in here. So we want a default value of null. Let's do city, varchar, just do 100, do not null, and then state, varchar. I want to keep this as state abbreviations, so I'm going to do 2, not null, because I don't want to have to type out everything or type out the whole state. Varchar, let's do 5 initially, and not null. All right. Does anybody have any questions about how I'm building out the table or the addresses table? Nope. All right, let's build out the guardians. So we can do create table, guardians, and then should I? Just copy this over for simplicity. So ID, serial, primary key, name, varchar 255. We want it to be not null. Phone number, we can leave that blank if we want it to. Email address, we want to include an email address. And then the address ID right here references the addresses table. And then likewise, at the very end, with students, we want a name, grade, date of birth, guardian ID. You can have create table students, ID, serial, primary key, not null. You really don't need that because it's not null by default, but you can keep it there if you want, but it's not necessary. Name, not null, grade, varchar. We can keep that blank if we want. Date of birth, we don't want to be null. This is all just how I'm designing the table. It can always be different. I can have this default to a certain grade if I wanted to, but This is just how I'm actually designing it. Does anybody have any questions about how I've designed the database for this new school that has addresses, guardians, and students?
I actually have one up in addresses. On line 2, you said default null. I haven't used that yet, so that just sets it to null if you put nothing in.
Correct.
So you have to annotate that if you wanted to do that.
Yes.
So what if
You-
you didn't have default null there and you didn't put anything in?
I think it would still default to null or none. I'm not quite sure, but just so you know, there is a way you can do a default for a field that if nobody puts in.
Oh, so you could default anything you want there.
I
Gotcha.
believe so. I've never done that before. I've never defaulted like a string or something. I don't know what that would look like. But yeah, you can default a value to a field if no element is put in there. So you can have a default value. And you're going to get into default values once we get into Django and start designing our database that way.
Thank you.
Yep. So with that, let's go ahead and actually create this database. So clear, I can do create DB and say like Platoon or like Platoon. All right, so I can do PSQL like Platoon. And there we go. I'm inside my like Platoon database. I can also check out Postico. I can see where's the mic. Do a quick refresh. There's my mic Platoon, and it's got no tables in there. If I do \D, it says did not find any tables. So now I can actually insert the schema P mic Platoon, insert example schema. It runs that, created the 3 tables, and clear. And I can see the addresses, guardians, and students. If I refresh here, I can see the addresses, guardians, and students. If I want to inspect it, line 1, line 2, city, state, zip code, I can do \D, addresses, same thing. ID, line 1, 2, there we go. All right. Does anybody have what questions do you have about creating the table? All right, let's create a seed file and create some addresses, guardians, and some students. All right. So I'm going to touch seed.sql, code, seed, SQL. Now we're in our seed file. So if I wanted to insert an address, a value into the address table, what are the keywords I need to use to do that?
Insert into
Values.
So insert into the name of the table, followed by the fields I want to insert. So I want to insert line 1, city, state, zip code. I don't need to include the ID because that's created by default. So I heard someone say values. So the values I want to insert, and I need to match up the position of line 1, city, state, zip code with the actual values. So I can say 125 West Clark Street, Chicago, Illinois. Do like 60605. And then always, again, don't forget to do that. And now I can do insert into 3 more values. We do 1, 2, 3 fake street, Chicago, whatever. And then 4, 5, 6 real street, 60605. Oh, there we go. All right. Let's see if these get inserted right away. So I can PSQL, like Platoon, insert seeds, error column 60605 does not exist. Line zip code values right here. So what is that? So the double quotes. So notice how all of them. So let's, all right, check that out. Highlight them all, do single quotes, come down here, clear the terminal, run that again. Cool. So you can't use double quotes when you're inserting into a database. All right. Now, if I want to quickly look at that, I can refresh that, and I've got the 3 values in there. Okay, now I want to insert into Guardians, insert into Guardians. You can also, if you want to insert the ID, you can, but you don't have to. So right here, I've got 1, 2, 3, and I'm not inserting the ID in here, but for Guardians, maybe I want to, just because. Address, address. Oh, where'd it go? I just want to look at addresses. So Guardian's phone number, email address. There we go. Email address, and then address ID. The values. Let's do 1. Sarah Connor. 555 334 1 2.
Hey Tom, I got a question.
Yep.
When you're entering in these arguments, do they have to be in order in relationship to how the columns are arranged?
No, they don't. I don't believe so. You can like mix up these, not related to the column, but you just kind of have to make sure that these values are corresponded to the same columns as the same order as this. But we can test that out, but I'm pretty sure it doesn't have to be.
Cool, thanks.
And then Sarah Connor's address is 1. And let's do 2 more. Sarah Connor. Eight 999 555 66232. Ruth at Gmail. And we're going to change this ID to 2, change this ID to 3, change this ID to 3, 2. The last person, I'll just insert me. 312 555 68. There we go. Tom at gmail.com. Cool. So if I clear that and I run that, so insert into Guardians. Uh-oh, what happened? So I inserted these back in here, but I'm running into errors here.
Is it because we tried to put in the ID?
Let's see. If I refresh this, crap, I just made double duplicate. Okay.
There's no semicolons.
Exactly. There's no semicolons at the very end. Thank you. If I run that again, Oh, cool. Insert everything. But now look how many fake like addresses I have. I have guardians. So what I'm going to do is rerun that entire schema file, drop table, create table, and then run the seed file. If I refresh there, same thing. Now I only have 3 here. I just want to get back to that.
Hey Tom, I got a question.
Yep.
For the address ID, on line 7, 8, and 9, all the way to the end in values. So why did you change from 1, 3, 2 instead of 1, 2, 3?
So right here.
Yeah, right there.
So I'm just deciding on what address Sarah Connor lives at. So the address ID, I want her to live at 125 West Clark Street because this is the very first address. This is the second address. This is the third address. And I want Ruthie Cohen to live at this real street address. And I want Tom Preet to live at this fake street. So this corresponds to the address ID. That's why. I could have made these any value I wanted between 1 and 3.
Got it. Thank you.
So with that, let's actually clear PSQL Mike Platoon. So now I'm in Mike Platoon, and I want to, so let's go back to this file. Say I want to find the address where Tom Preet lives. So I'm inside of here, and now I can select star from like addresses, and there I've got all the addresses, and I can do guardians. I can select all the guardians, but I want to know where Tom Preet lives. So does anybody, so how do, like, if I wanted to get the address of where Tom lives, I want to start here and then bring in the addresses where, you know, address ID equals.
Select from where.
So select from where. So if I'm going to clear that. So select everything from guardians. Okay. And then I can say what, where. So I've got the entire guardians table, but I need the addresses as well. So how do I bring in the addresses table? So I can join the addresses table. So I'm bringing in the addresses table on. So I'm saying, like, where do I want the join table to link up? Or these two tables to like link up or overlap? So on addresses dot ID equals guardians dot address. Is it addresses ID or address ID? So address ID. So I'm grabbing all the guardians, the entire guardians table. I'm joining the addresses on essentially where the address ID equals the guardians dot address ID. And then I'm saying, hey, where the guardians dot name equals, what do I want? Tom Preet. So if I do that, so I grab the entire guardians table and I join the entire addresses table as well. where the name guardians.name equals Tom Preet. So it outputs the entire, essentially where Tom Preet lives. So that's me starting from the guardians table. What questions do you have about that?
What would it look like if you had two addresses?
If I had two addresses,
Yeah.
what do you mean? Like if Tom had two addresses?
Yeah, I guess I get confused on when a single reference, like a user, has multiple, I guess, instances or relations in a table.
So if a guardian can have multiple addresses, this is where we'd have to have like a third table called guardians addresses. So where a guardian can have multiple addresses, and we'll get into this later after this little this part. That's where we're getting into like more complex databases. But you essentially have to create another table where it has, let's actually create it. It'd be like, real quick, guardians addresses, something like that. So you're bringing in multiple tables. You have an ID, a primary key, which is an integer. And then you have a guardian ID, int, foreign key. I think it's like a many-to-many. See what that looks like. Oh, so right here it's just gonna like so, and then you're gonna have addresses or address ID. And then inside the guardians, you wouldn't have that. So that's what that would look like. So that means a guardian can have multiple addresses because you can have a guardian ID, a guardian, multiple guardians here. So a guardian can have multiple address IDs, and an address ID can belong to multiple guardians. This is where a many-to-many relationship. And this is where we get, yeah. So that's what that would look like. But you'd have to create another table.
So when we create like the scheme, that table that you just deleted, that will be on the top? Would have been at the top?
Right here?
Uh-huh. It would have been like the first table that we would have created?
No, not necessarily, no. It'd probably be one of the last tables you actually create because the other tables rely on it. Or this table, I'm sorry, the guardians addresses table relies on the addresses table and the guardians table. So you'd have to create the addresses table and the guardians table before you can create the guardians addresses table. But that's what a many-to-many relationship looks like. What other questions do you have? So for this first query, select everything from the guardians table, bring in the addresses table on where the address ID equals the guardians.address ID, where the guardian's name equals Tom Preet. But so that's what's starting from the guardians table. But say we started from the addresses table. We can, same thing, select everything from addresses. Oh. Let's see if this works. Hold on. It's a weird query. I don't know if this is actually going to work. Hold on. Oh, that's weird. Okay. So select addresses. So I'm essentially grabbing all the addresses from the guardians table. I'm joining the addresses table, and I'm just literally printing off the addresses. It's another way to do it. It's a little more confusing. You can also see how it like returns. So select everything, but I'm saying like, hey, create a table, like a header of addresses from Guardians. But it doesn't look that pretty. There's another way we can do it. The same thing, clear. I can do select guardians.name. You can addresses dot line 1, addresses line 2, addresses. So you can just include only the values or only the columns you want. Addresses dot state, addresses dot zip code from Guardians join addresses on same thing, addresses dot ID equals Guardians dot address ID, where Guardians dot name equals Tom Creed. So I just grabbed the Guardians that name, so I don't have to include where'd it go? Where'd it go? Damn it. So I don't have to include everything from the Guardians table. I just want the first name or the person's name. And likewise, I can do the same thing. I can just grab, select everything from the addresses table by doing the star from Guardians join addresses on same thing, addresses dot ID equals Guardians dot address ID, where Guardians dot name equals Tom Reed. So now I'm literally just grabbing the address instead of including the name or just including everything. What questions do you have about 4 like different ways you can display the address? Any questions? Nope. All right, let's keep going. So now I actually want to create a couple of, I want to create some more users. So I'm going to insert into students, name, grade, date of birth, values. Mike, he's got a grade of 1, date of birth, and he lives at address where an ID is 3. So I inserted that. And now I want to insert another student. Same thing as before, Joan Greenwood, ID of 5, or I'm sorry, grade 5, born 2005, lives at the same address as Mike. So I can select everything from students just to see everything. Uh-oh. What happened? Mike Platoon. So Mike, it only has 2 rows. Did I write over something? 3, Guardian. Oh, I'm inserting into students. I was thinking of guardians. So I've got two students, Mike and Joan Greenwood, but my database, so like star from, so notice I have the last name in here, but I'm missing Mike's last name. If I wanted to alter and update Mike's last name without manipulating, without dropping the database at all, there's a way I can do that. So if I wanted to update the student Mike, I can do, does anybody know the keyword to update a value in a database?
Isn't it update?
Yep, simple update. The name of the column, or not the column, the name of the table, update students, with set name equals, instead of Mike Crete, I want to capitalize Mike. Actually, let's do it Mike Greenwood. So I'm changing the name for this new person that I'm changing in the database. I'm setting the name to equal Mike Greenwood. Oh, whoops. Oh, I just messed that all up. I'm just going to quit that and start over. Clear. Let's try that again. So updates, students, set name, Mike Greenwood, where ID equals 1. Because I think if I look at Postico real quick and students, I can see Mike has an ID of 1. So I want to change Mike's name. Where we go. So update students table. I'm setting the name to equal Mike Greenwood, where the ID equals 1. Click that. I updated 1. So I can select everything from students table. And there it is, Mike Greenwood. I've got Joan Greenwood. If I come over here to the Postico, if I refresh it, I got Mike Greenwood, Joan Greenwood. So now, I just want to look. So I've got students. So say I want to grab all the names of the students where the guardian is Tom. So I'm just going to look here. So there's the students. The guardian ID is 3. And Tom right here is a guardian. He's got an ID of 3. So if I wanted to grab, oh my God, there we go. So I'm here, students. Let's go here. So I can either start from the students or I can start from the guardians. But let's start from the students. No, you can't really start from the student or guardians, but maybe you can. I think you can. But let's start from the students and grab this student's guardians where, let's grab all the students whose guardian is Tom Preet. So I can do select, students. I can either say select everything from students. I can join the guardians table. So I'm bringing in the guardians table on students dot guardian ID equals guardians dot ID where guardians dot name equals Tom Preet. If I do that, I get Mike Greenwood, Joan Green. So I'm essentially grabbing all the students. So I'm just grabbing all the students, and I'm joining the entire Guardians table. But maybe I just want the student name, because right now I'm grabbing all this data right now. I don't want all of that. I just want the student name. So I can literally just go students.name. So just grab the student name from students, join the Guardians table where the students that Guardian ID equals Guardians.ID, where the Guardian's name is Tom Breed. And now you can see, so it's just grabbing the names. What questions do you have about that? So now, let's see if I want to grab, so let's just, so here are the other, was it Mike? So here it is, Mike Greenwood. Say I want to know where, so Joan, I want to know where Joan Greenwood lives. So I need to know where Joan Greenwood lives, but there's no direct way to grab Joan's address. So what I have to do is start in the students table, bring in the Guardians table, and then also bring in the addresses table. So I can either start here, go that way, or start from addresses and go that way. So let's actually start from the addresses table. So I'm going to select everything from the addresses table. Then I'm going to join the Guardians table. Join Guardians on Guardians.id equals addresses. No. Guardians.addresses. And join in addresses.id. So I'm starting at addresses. I'm joining the Guardians table on where the address ID equals the addresses.id. And then I'm going to join in the students table on students.guardian ID equals guardians.id. So I've started here, addresses. I'm joining the Guardians table. And now I'm also joining the students table where the Guardian ID equals the Guardians.id. And now where the student's name, students.name, oh geez. Let's actually go on each separate line just to break it up. It didn't work. So we're students.name, I guess, equals Joan Greenwood. There we go. So what I did is started from the addresses table, joined in the Guardians table where the Guardians.address ID equals the addresses ID. And then I joined in the students table where the students.guardian ID equals the Guardians.id. And then I'm saying, hey, where the student's name equals whatever. And I'm only grabbing that address. I can do the same thing. If I just grab everything by doing select star, it's got each table all next to one another. So I've got the addresses table, I've got the Guardians table right here, and then I also have the students table right there. What questions do you have about joining multiple tables together? No questions? All right. As I mentioned before, creating a schema is actually the most difficult part of designing a database. So let's actually create a new one. Let's create a brand new database that let's create an app, like a workout app. So no one can go to gyms anymore just because of COVID. So everyone's starting to work out from home or whatever. And they need to create some VC comes to you or entrepreneur comes to you and be like, hey, I have an idea. I want to create a workout app that has users, workouts, exercises, and go ahead and let's build that. So the first thing we need to do is actually design the database schema before we actually start building the app. So what do we need? What kind of tables do we need for creating a workout app?
Users.
All right, cool. We need users. We're just going to keep it super simple. Users have an ID of primary key. That's an integer. Oh. And it has a name. Cool. That's it. What else do we need? How about a workout or an exercise? Or how about both? Because usually a workout consists of multiple exercises, right? All right, so let's create a workout table, or workouts. Workout table, ID, PK, integer, and let's just say like the type of workout, and it's a string. So it could be strength, endurance, whatever. And now we're gonna have an exercise. Or we could say exercises. ID, primary key, integer, and let's say like the name of the exercise, string, and like a description. Cool. So now this is where it gets kind of confusing. All right. So an exercise type, so if you do an exercise, so say it's like jumping jacks or push-ups or like running or sprinting, or if you're working out with weights, like curls or something like that. And an exercise, so it's just one of those, like jumping jacks. But a workout can consist of multiple exercises. And you can also have different workouts that incorporate the same exercise. So how do we resolve that? So one workout, like a strength workout can have push-ups, but like a different type of strength workout can also have push-ups.
Should we give certain exercises a type as well? And try to match them up? I don't know. I'm just thinking out loud.
Like how to connect them?
Yeah, something like that.
So this is where I understand what you're trying to get at. But this is where we'd want to bring in like an actual, like a different table. So we can say like, hey, this is where a many-to-many relationship comes in. And many-to-many relationships are like the most difficult or complex type of relationships. So you can have workout exercises. And then we have an ID of a primary key with an integer. And then we have a workout ID integer. It's a foreign key. A workout .id. And then down here, we'd have an exercise ID integer foreign key exercise .id. So this is what a many-to-many relationship would look like. So a workout. So you'll in this table you'll have multiple workout IDs of the same ID, but with different exercise IDs. And likewise, you'll have in this table you have multiple exercise IDs of the same exercise ID, but they'll have different workout IDs depending on which exercise that workout belongs to.
So Tom, I think I have a little bit of a confusion about what kind of problem that solves, because like Dylan was saying, why couldn't we just have like a workout type on the exercise table, and then it's like a foreign key of the workout it goes to? Like what does workout exercises, that additional join table, like what does that help us with? Like what kind of query?
So if you want to say like, all right, what workouts have, I want a list of workouts that have this specific exercise. And it would list all the workouts that have a very specific exercise. But what you're saying is, why not add a type onto here in the exercise? So like type string.
Well, no, the type would be like the foreign key matching the ID of the workout. So then if you queried it, you'd be like, oh, all workouts with, or I think I might be thinking of it backwards sort of, but you could still see the relationship between what exercises go to what workout, because you would be able to use that foreign key. And I feel like that's what that join table does, but I just don't understand why we use that sometimes versus why we don't.
So when you're creating exercise, you're only like push-ups. There's only one push-ups exercise in the exercise table, and you can't have multiple IDs that belong to that exercise. So if we were to actually create it, see if we can create it. So let me just pull up a spreadsheet, because like if you want to kind of visualize it, a spreadsheet might be a good way to. So say we have workouts, exercises. Can you see that? You have an ID. What was it? ID, name, description. Name, description, ID, and type. And you're saying, what if we had a foreign key? Like a foreign key of workouts.id type of thing? So if you had like push-ups, I don't know, some description. And then you add an ID of 1, 2, 3. And then like type, strength, flexib, and strength 2, because you might have like another strength workout. Push-ups can belong in two different workouts. So it can belong in strength, like the first one and the second one. Are you with me?
Yeah, I'm following.
Okay. So right in here, if it was just, if I just had a workout ID on the exercise, like this, this push-up exercise can only belong to one workout. But it can technically also exist in another workout like strength 2. And how can I, like, there's not a way I can, the way this database is set up, I can't relate push-ups to strength 2 at all right now. So that's why you would need a workout exercises table with an ID, workouts.id or underscore ID, and exercises ID. And so here I can do workouts there. So the workout ID of strength is 1, workout and the exercise ID of 1. Let's just do 2, 3. I'm going to delete this right now. And I don't know. So right now the strengths, push-ups can belong in this strength workout by this, because so ID of 1 there, as well as the exercise ID of here. So there's push-ups, but also technically it can belong in strengths too. There's strengths, another. So this is just a visual representation of the tables. So workout ID of 2, or I'm sorry, workout ID of 3 with an exercise of 1. So that's why we need, this is a many-to-many relationship. What questions do you have about that?
The workout exercises ID would be 2 for the second one, right?
For this one?
No, the primary key under workout exercises.
Workout exercises. Oh, yeah, sorry.
Okay. No, then
No, yeah.
That being said, yeah, I think I get it now.
Yeah, so this is just, oh, what the hell? This should, like so. And so this workout exercises, so I can say like, in workout ID of 1, it also has jumping jacks in there, but also the workout ID of 2, so the flexibility workout might also have jumping jacks in there as well. So that's literally what this table looks like.
Is this ordered at all? Like say the workout had, like you wanted to do push-ups and then you wanted to do sit-ups and then you wanted to do push-ups again.
So if that's the case, that's where you'd bring in on this workout exercises table, you'd say like order, and then workout 1, that's the, or I'm sorry, say maybe you want jumping jacks to become before push-ups in the very first strength workout. So here's the first strength workout ID of strength. Here's the exercise of 2, and then the order we'd want to be the first one. So you'd have another column on here to determine the order. So you can have other columns in the many-to-many relationship. Did I answer your question?
Yeah.
Yep. Does that help, Michael?
Yeah, it clarified it beautifully, Tom. I appreciate it.
Yeah, no problem. And that's where the most trouble comes into as far as database design and is like the many-to-many relationships. So again, with a user, So we're almost done. But this is the thing I really wanted to emphasize is this many-to-many relationships using this, what they call it a join table, but it's really just another table. So then again, you can have like user workouts, ID, primary key, integer, user ID equals, oh, what happened here? Integer, foreign key, user.id, and then workout ID, workout. So this would be like another many-to-many relationship because a user can have multiple workouts, or user can work out different. You have a different workout each and every week. So we can also say like week equals date, or of like what the date is. Actually, I'll just say day. So what workout did a user work out per day? So now you can see that how the entire database is connected. So now technically I can say, hey, what workouts or what exercises did a user do on a specific day? So I come into here, join the user workouts table, join the workouts table, join the workout exercises table, and get to the list of exercises from the user table.
So it won't be uncommon to have a query that's several lines long.
No. But what's nice is when you get into an ORM, it makes the syntax a lot cleaner and a lot more intuitive. So you're not going to have you're going to get past all this raw SQL with massive queries. Hint, hint, join tables Friday, wink, wink. All right.